Okay, so question number 2 here, basically a question related to the A2 topic, have to do with the free body diagram. So you did a good job, yes. You identify the tension, right, along the direction of the string, and it should be upward so that it can keep the mass, the ball, attached to the string, and then the string is attached to the ceiling. And then you also have the weight of the ball, so that's good. You got the two forces of interest here. And now the second question, determine the acceleration of the truck. So yes, so this is a good equation. A equals to F over M, and the F here should be the F net, right? So how do we know that the F net here should be the F tension times with psi of 30? So just come here. This is a vector addition. If we analyze the tension vector into two components, so we can see that it will have a vertical component like this, right? This is the vertical component, which should cancel out with the weight. Because if it doesn't cancel out, then the ball will just fall into the crowd, right? And it also have another component here. That is the horizontal component, the TX here. And this is actually the force that make the ball here along with the string become a pendulum, so it can go in like back and forth here. Okay, so you can imagine like the tension has been analyzed into two components, the horizontal and the vertical. The vertical balancing with the weight itself, and we just have the horizontal left. So this horizontal left here turns out to be the F net, okay, because this one cancel already. Does it make sense? So that's why you have it here, the F net here equals to the tension times with psi of the 30. Why? Because this is like the tension. This is the component, right? We know which angle here, this angle, to be 30th, right? 30 degree. So then this one should be, this is what? This is a right triangle. So this one should be the hypotenuse. This one is the hypotenuse times with psi 30 degree, because this one is the angle opposite to the psi. So you got this one. Then you should plug in the mass of the truck, and then from there you can solve for the acceleration, right? Yeah. But another thing, we don't know the tension yet. So we need to find the tension, right? So here, once again, you can see that the component Ty of the tension actually cancels out with the weight. So don't you have another relationship, right? Ty equals what? Equals to weight equals to mg. And Ty itself is actually equal to the tension times width. That's right, this is 30 degree, this is also 30 degree. So this part here adjacent to this one, right? So that should be cosine 30 equals to mg. So actually you can find the tension equals to mg divided by cosine 30th. So if you just plug it back in, you can find the A here equals to the tension times with psi 30 degree over the mass of the truck, but the tension itself E equals to the mg over cosine degree times with psi of 30 over the m. So we can see that m cancel out. What left here is just g times with psi 30 over cosine of this one. So that should be g times with tangent of the 30, right? Okay, so this is one way for you to determine the acceleration. Let me see if we can have any other way to make it like even faster. Yeah, I mean, if you have a look at this one, you can see this is the tension, this one balance out. So actually the acceleration is this way, right? This is the acceleration. You also have this one as the g. This one actually is a vector itself, right? This one is a ma, this one is a mg. So if we just simplify this one for m, this is also the same direction of the vector, right? So actually you can also see that the vector a and the vector g here forming a a right triangle as well, right? And this one is like 30 degrees. So if you can see it right directly from this one, you can see really quickly that A is just equals to the other side of the right triangle times with the tangent of the 30 degree, which is like the opposite to itself. So it can be even more straightforward if you can see the vector like this. Okay, so please let me know if you have question about here this one. Okay, thank you.